Waterjet cutters. This is, again, a stock photo of a Wazer, but I do have a Wazer. How do water jets work? It's pretty straightforward. You have a jet of water, but the water doesn't do any cutting. What actually does the cutting is garnet, basically a very specific fine powdered garnet. And we have an example of some of that stuff over on the left here. Because of that, essentially a water jet cutter is a very fancy kind of sandblaster. The advantage of this is that anything that can be cut essentially can be cut in a water jet cutter. So whereas the laser cutter is cutting, in our case, organic materials, this can cut metal, it can cut stone, it can cut glass, ceramics, all kinds of stuff can be cut with a water jet cutter, which is fantastic. Now, it cannot etch. There's no etching on a water jet. The only thing it's going to do is it's going to cut straight through the material. And that sounds great, except there's a lot of downsides with a water jet cutter that we'll get into. But yeah, let's talk about the process first. So because this thing can only cut, it can't etch, the only thing it's going to be able to take are vector files. So you're using Illustrator. Inkscape is the open source alternative to Illustrator, or an actual CAD program like Fusion 360. Now you'll notice the Wazer on the top here is configured with Wazer software, and the Omax machine, the Protomax down at the bottom, is configured with Omax software. Water jet cutters are not super common as a hobbyist machine, and so basically all of their software to control them is proprietary. You'll be using some kind of vector file, DXF or an SVG as input, but the machine is actually going to be controlled by its own proprietary software. So when you talk about water jet cutters, people talk about the amazing things they can do. They can cut through super thick material like these giant pieces here that I did not make, or the extreme precision like these very small pieces that I also did not make. Realistically, if you're looking at a water jet cutter that could conceivably be in a home shop, you're going to be looking at something like this. This is something I did make. This is an adapter plate to allow me to take this Virpil joystick controller and attach it to a simulation cockpit that I built. So you can see it's pretty straightforward. We have essentially a rectangle of metal with holes cut out so that you can screw the joystick to it and slots so that it can be mounted to the frame. This is fantastic. The holes to mount to the joystick, there's not much play there, so they need to be really, really precise. The water jet cutter has no problem doing that. And this is a 1/4 inch thick aluminum plate. So sounds great, right? Like you make a pretty straightforward DXF file or SVG file in Illustrator, you put it through the water jet cutter software, and this part comes out. Sounds fantastic, except this part took 38 minutes to produce. Now that doesn't sound too bad, but it used 12 pounds of abrasive to actually make this cut. Now, abrasive itself is not crazy expensive, but the shipping is. It's basically specialized dirt. So it's heavy, and given that once shipped, you're looking at somewhere between $1 and $2 a pound for this abrasive. So if we just go with a $2 a pound figure, this is $24 in expendables. That does not include the cost of the part. That does not include the cost of the aluminum plate. It does not include the cost of operating the machine or the electricity of the machine or anything else. That's just the abrasive. You're looking at $24 to cut this part. So this is the reason that it's problematic for hobbyists to own these machines. If you want to get abrasive material to you for less than $1 a pound, you're generally going to have to buy it by the ton. Alibaba will be more than happy to ship you material by the ton. So realistically, what you want is you want to know someone that owns a water jet cutter. There are commercial services for this, though. There's one called Big Blue Saw. It essentially is, you send them a design, and they will farm it out to someone that owns a giant water jet cutter, and they will cut the parts out and mail them to you. So even if you're not interested in buying a machine, it is going to understand how the machine works and operates so that you could sub the parts out to somebody else that can operate it more economically than you can. Now, we talked briefly about kerf with the laser cutter. I said the laser cutter for a Glowforge is like 0.08 of an inch. Kerf on a water jet cutter is much more significant. You can see here, like you can actually tell that there's material missing here. So if you have something that has very, very tight fit tolerances, that's going to have to be compensated for, either in the software that that's running the water jet cutter or in the actual design itself. Another problem that water jets have, lasers sort of have this, but it's a much bigger deal with a water jet, is taper. The size of the kerf, the material that's being obliterated by the water jet, is smaller on one side of the cut than the other, and generally it's smaller at the top and wider at the bottom. This is a bigger deal the thicker the material gets. If you're making something like a gear, you want the teeth of the gear to be flat. That's not super great with a water jet cutter. So a lot of the gears that you see being produced by water jet cutters in demos are really thin, where that twist that the taper causes isn't that big of a deal. On the other hand, taper can actually be a benefit. If you're doing assembly, taper is sort of an automatic edging for the material. So it will point its way towards fitting. So if you had a cylinder that had to go into a hole, you would take the hole such that the narrow side of the taper, or the larger diameter part of the taper, is towards the assembly. So you push them together and it guides the pieces together. So in that case, it could be an advantage. What's not an advantage is the cost of these machines. So Omax is the big name in waterjet cutters. This is the cheapest thing they make, and it's $26,000. Very, very expensive. The Wazer was an active attempt by a group of people to make a waterjet cutter that was somewhat affordable. Still $10K to buy this machine. So very, very expensive. Also, especially in the case of the Wazer, these machines are extraordinarily messy. The abrasive, I mentioned for that one plate, it took 12 pounds of abrasive. Imagine 12 pounds of material. Now, most of that material goes into the machine. Even with the covers, though, I have garnet sprayed on the walls. You sweep it up off the floor. Omax's bigger machines, they don't even try. The machines are just completely open, and you just accept the fact that this garnet is going to decorate the interior of your shop space. Okay, vinyl cutters. Vinyl cutters are absolutely amazing and fantastic, and I wish people talk more about them, especially if you are interested in decorating fabric or several other applications. These machines are absolutely wonderful. Now, most of the time when we think, oh, vinyl cutter, it's going to cut a shape out of something. That's not really the power of the machine. The cut is extraordinarily precise, but not just precise in the shape that it makes, precise in the depth. So here in this illustration, you can see we have material and we have a carrier, and a lot of materials meant to be cut in vinyl cutters are like this. The blade will cut through the material, but not through the carrier. So imagine that you had a design that you wanted to cut out, and you're going to use it for decorating. So let's say the material is really thin. It's either like a cardstock or, in this case, a vinyl, something like that. So you have a complex design that is actually hundreds of individual pieces. If you cut that with a laser cutter, you're going to have hundreds of individual bits and pieces to fool with. If you cut it on a vinyl cutter, the carrier holds the pieces together while they're being cut. So they're all together, their distance separations are all perfect while you're working on the cut, which is fantastic. In terms of materials, there's lots. This is a subset of one vendor's materials that they provide. You can get holographic vinyls, retroreflective vinyls, which are you can't print a retroreflector, but you can get it as a vinyl. You can stack them, so if you want to do multiple colors. If you're doing dye sublimation, there are certain vinyls you can actually dye sublimate onto. There's also a couple different kinds. There's heat transfer vinyl, which is typically used for applying to garments. You apply it with heat. There's also permanent adhesive vinyl, which, like it says, permanent adhesive. If you're putting it onto hard goods, things like that, you'd be using the permanent adhesive vinyl. These machines are vector machines only, so you're going to be using your DXF or SVG files. In the case of the more industrial machines, like the GraphTech, which is a cutter that I own, you have a USB cable and a plug-in in Illustrator. So in Illustrator, instead of saying file print and sending it to like a color printer, you say file cut and it sends it to the GraphTech and it will control it directly. In the case of the Crickets, which are also a super popular, fantastic cutter, they have their own software. And their software will either connect to the machine via USB cable, or they have options for like their Maker 3 that will actually let you control it via Bluetooth. So this is a piece of vinyl that has been run through a vinyl cutter. Now, unlike a saw or a laser cutter or a waterjet cutter where material is being obliterated to separate the two parts, the knife of a cutter just separates them. There's no waste material. And so when it comes out of the machine, it looks like this. It's almost impossible. Well, actually, in this picture, it actually is impossible to see where the cuts have been. However, the next process is you would weed it. So you're going to take those pieces that have been cut that you don't want, and you're going to remove them from the carrier. At this point, everything's still tucked to the carrier. Here is what that part looks, the exact same sheet. It's been cut to a little smaller size, but the parts that we don't want have been removed. They've been weeded out. So once we have this, you can see that we've got several distinct individual pieces, but they're all being held together by the shiny carrier that you can see there. So when you take it to the part you actually want to apply this to, you don't have to worry about getting the spacing right. It's all held together by the carrier. So here, this is actually what it looks like when it's applied to a garment. So you can see that the exact proportions of everything is exactly the way it was on the carrier. This is a heat transfer vinyl. Obviously, this is a thing that was applied to a shirt. This is 100% polyester. So you can get heat transfer vinyls that are capable of going on cotton, 100% polyester, cotton poly blends, rayon, nylon, lycra. If you can think of a textile that human beings put on themselves, you will be able to find some type of vinyl that works with it. Another great thing about this is occasionally people, especially if they're making costumes, they will want to put an applique on a garment but have no visible stitching. Now, normally, if you match your stitch color to the applique, no one's going to be able to see it unless they are uncomfortably close to you. But some people with almost irrational hatred for visible stitching are really, really, really against that, especially if you are making a costume based on some type of comic book character where they don't draw stitches. So in this case, you can actually get a design applied to a garment with no stitching whatsoever. And in addition to these colored vinyls, you can also get vinyls that replicate the look and feel of leather. So here's some other examples. We have a really bright orange heat transfer vinyl applied to a t-shirt. On the right, we have a metallic permanent adhesive vinyl attached to a cell phone cover. And cell phone covers are typically made out of materials that things don't stick to well, but the permanent adhesive vinyl is amazing stuff. A lot of the times the adhesive is made by 3M, and the stuff is almost magic. Here we have another example of something you do with a vinyl cutter. So what was done here is vinyl was cut and then used as a template. So the vinyl was cut in the vinyl cutter and applied to this sheet of glass. Then this glass was sandblasted. And so everywhere the vinyl is not protecting the glass, the abrasive from the sandblasting hits it and etches it away. Now, someone at the convention asked, hey, could you use a laser cutter to do this? Not normally. So most of the time, there's two ways to etch glass. There's blasting it with a sandblaster, or the more common hobbyist way is to use a kind of paste. Now, it's worth noting that if you go into a laboratory, almost all the chemicals are stored in glass because glass is not reactive. That's why we use it in labware. If you are messing with something that has the capability of etching that glass, it's probably really nasty stuff. And the most common thing that you're going to run into is hydrofluoric acid. And it is. It's nasty stuff, so you have to be careful with it. Most of the things that are used for etching with the hydrofluoric acids are going to be some type of chlorinated plastic, which means you can't run it through the laser cutter. If you had a metal template that was able to tolerate the acid in theory, but you're not going to do that on a hobbyist laser cutter. So generally speaking, most of the time, you're going to be using a vinyl cutter to cut out a template, apply it to your piece, and then either etch it with your hydrofluoric acid cream or your sandblaster. And here's some example machines. We've got the Graphtec on the right, which is the machine that I own, and then you have the Silhouette and the Crickets. The Crickets are actually fantastic machines. I was very surprised the first time I saw one of these things in person. You might think, oh, the Graphtec's more expensive, it can work with big rolls, it must be the better machine. That's not necessarily true. Remember, if the machine is using rollers to feed the material back and forth, there's always going to be some possibility for slippage of the material. So the big things like the Graphtec typically will say, oh, they can keep the material reasonably accurate to a certain distance. But you can easily load a 100-foot roll into these machines, and they will not stay accurate over that 100 feet of distance. So they're not as precise. The Cricket has the option to either be fed from a 12-foot roll, which is where it gets a 144-inch cutting dimension from, or a tray. You can get more positive grip on the tray. And so just because the Graphtec is more expensive does not necessarily mean that for smaller designs, it's going to be better than the Cricket. The Cricket is also a pretty well-built machine. I mean, that Cricket Maker 3 that you see there, that weighs 22 pounds. It's not so heavy that you couldn't move it around, but it's pretty well built. Okay, 3D printers. We'll spend the least time on this because most people are familiar with these things if you don't already own one. And their operation is pretty straightforward, and there's a zillion YouTube videos about these things. So briefly, the most common types of 3D printing, you've got Filament, also known as Fused Deposition Modeling, FDM, Fused Filament Fabrication, FFF. I never heard anyone say FFF. Resin printers. These are a lot more popular now. They'll call them stereolithography machines or masked stereolithography, which is a slightly different way that the modern ones work. Or powder, like selected laser sintering. The powder machines, almost industrial only. They're super expensive to both purchase and operate. The filament machines, their operation is pretty straightforward. We'll get to in a second, but they do require 3 different drive motors, X, Y, and Z. A resin machine only requires 1 drive motor. So in terms of moving parts, resin machines have way fewer moving parts than a filament machine does. Okay, filament machines. If you've ever seen someone decorate a cake with a piping bag, they have a bag, they put delicious sugary things in it, and they squeeze it out onto the cake. That's basically the way a filament machine works. Instead of tasty, delicious, edible things, it's using hot plastic. So basically it has plastic from a filament that it moves through a head, it heats it up, and then it oozes it out through a tip. That's basically how the machines work. There's a ton of different materials. Basically any plastic that you can get that can be melted at a reasonable temperature and then spread out can be run through these machines. Now, it's worth noting there's no such thing as a pure substance. So PLA is a very popular 3D printing filament to use. If you have PLA that's not kind of like a whitish gray, there's something in it that's not PLA, because that's the natural color of PLA. So if you get black PLA, it's PLA plus something else to give it color. And frequently, in addition to just colorants, there are other materials added. Some of them make it more plastic, make it more workable. All of these additional fillers, they're also getting heated when the material heats up. So depending on the filament you're using, the outgassing from the heaters can outgas some pretty nasty stuff. PLA is generally really mild, but when you get into things like ABS plastics, especially heavily modified ABS plastics, they can have some pretty nasty gases. And most of the 3D filament machines that you get don't have any type of exhaust gas system on them. So it's something to think about when you're working with these machines. Resin machines. Resin machines are actually really, really old. The technology is very old. They would have a laser scan over this UV curing resin, and that would make one layer. Then they would pull that layer up and then put it back down into the resin, and they would shoot the next layer. And you do layer after layer until you get a completed part. Now, suspiciously, you'll notice that these machines typically come in two sizes, a small size and a bigger size with almost nothing in the middle. It was realized that instead of using lasers, what if you just had a big UV light source and you masked it off? And they said, well, what are we going to use to mask it? And they said, what about an LCD screen? We'll have an LCD, and it will mask off the parts that we don't want to be exposed to UV. Well, that's great, but that means the mask is getting hit with the UV, and LCD screens being baked by UV all the time is not good for their life expectancy. And then they realized, wait, what if we had LCD screens that were almost disposable? Like, let's say they're a consumable part. Let's say they last, 500, 1,000 hours or something, and then you just replace them. Well, that sounds kind of expensive. If only there were some place where we could find super mass-produced LCD screens. And so you get resin printers that are suspiciously cell phone sized and suspiciously tablet sized. And that's basically why these machines became so much cheaper over time, was that they realized, hey, we can just use these mass-produced screens. They're a lot cheaper, and even if they wear out, we'll make them replaceable. And so the resin printers have become a whole lot more popular. Resin printers are extremely accurate. They're slower to print than a filament printer, and they're messy. The resin used in these printers is not water-soluble and cannot be dissolved by your normal cleaning agents like your dish detergents. So how do you clean it? And the answer is alcohol. Alcohol will dissolve this stuff. So it might not seem like that big of a deal, but when you realize that the only way to clean this stuff is to scoop it up and then use alcohol to clean everything, it can get really, really messy. It's not like you can just take some soap and throw it on there and clean it up with a mop like you normally do. Spills are annoying and they're a pain. Also, you need to clean the vat out that holds the resin. Like when you're done printing, there's going to be some leftover resin, and that's sort of annoying. Powder machines have their own way of working. They stack layers of powder, a laser hits it, and it fuses the material to itself and to the layer below it, and they continuously roll powder over it. They use different kinds of supports because normally the material is supported by the pool of powder that it's floating in. These machines are, like I said, very expensive and not super conducive to the hobbyist. Also, the waste is kind of high. So if you're just making one part, it's important to remember that the powder that is not used, and also when you go to a certain height, you will fill, by necessity, you will fill the build chamber with powder up to that point, regardless of how much you used. The Formlabs Fuse 1, which is a powder printer, the documentation states that when you fill the printer, the most used powder you can use is 50%. So you're losing tremendous amounts of this powder over time. And the powder is also really, really fine, gets everywhere, makes a mess. It's expensive. It's good to know that this process exists, but this is not a machine that you're going to be owning, most likely. There is a lot of software involved with these things. So you can use any of your... Now, we're not using flat files anymore. We're not using SVGs, DXSs. Now we're using three-dimensional files. And the most common is the STL file. Someone at the con asked about other file formats. A lot of these applications do support other formats, but STL is supported by basically everybody because STL was what the original ancient machines used, and it's just ubiquitous through the industry. So ZBrush, Blender, Fusion 360, any program that can produce a 3D file, you would export that as an STL or possibly another file that your particular slicer supports. Here you notice we have a lot of different slicers. This isn't even all of them. This is a small sample. The slicer will either communicate with the printer directly via USB cable, or it will output a G-code file, which is what these machines natively use to do their work. Now, People often ask about, well, which is the best one to use? And what I say is, once you've found the printer that you want to use, it will come with instructions on how to print a test part to verify that it's all working. The instructions to print the test part will mention a specific slicer by name, and they'll have instructions to use that. Use that one first. Whatever that is, give that a shot, verify that the printer works. Once you've done that and you've gotten familiar with that and you're comfortable with it, then you can say, oh, are there features or other interesting things in these other slicers that I might want to use? That way, if you go to another slicer and it doesn't work, you can always go back to the original manufacturer suggested slicer for their demo part to make sure that the printer is actually functioning correctly. Because there's no point in chasing a problem in the slicer if the machine as it was shipped had some type of defect in it. So here's some examples. This comes from a resin printer. This is from one of my resin printers. This is actually the test part that came with it. The big rectangle, the thick blue lines there, is 1 inch across. And so you can see that this cube has a very fine lattice work in it, and you can see the support structures for it still attached. So this is an example of the kinds of resolution and detail you can get with these printers. This is also an example of something that came off that same printer. This is another piece of an escape room part. The part on the right is designed to fit into the socket on the left. They were part of larger structures, but these were essentially, as they came off the machine, they were then painted and they were put into the part and they were used in the escape room. Some example machines. So on the left, we have some Creality machines. These are your filament machines. And on the right, we've got some of the resin printers. Now, with a filament machine, as the economy stands today, if you get a machine that has twice the printable area, it will not be twice as expensive. It will be less than twice as expensive. So generally speaking, as the machine scales up, the cost per unit volume goes down. Now, is that extra volume in dimensions that you need to use? Depends on your specific application. The resin printers are almost exactly 1-to-1. If you get a resin printer that's twice the size of another one, it will cost almost exactly twice as much. The Piopoli Phenom L is the printer that I have currently. So it's worth noting that it seems like, oh, if I'm willing to blow lots of money, I could get this big printer and it would be fantastic. There is a very legitimate case to having both a large format like the Phenom L and a small format like the Mars 2. In order for the resin printers to work, you have to fill the base with resin. The larger the base, the more resin you have to put in it, and the bigger the mess it's going to make. The Piopoli requires basically a liter of resin before you can start printing. That is a lot. Whereas the Mars requires, it's a lot smaller and a lot easier to clean up. So if you're interested in printing and something like the Mars is going to be able to have the envelope that you need, it's literally 1/10 the price of the Phenom L. So even if you're interested in, hey, I want to print like an Iron Man mask all in one go, which the Phenom L can do, you should consider the smaller machine, especially since maybe there's different kinds of resins, and resins, the fumes are not super bad, but they can accumulate over time if you leave the resin in the reservoir. And some people are sensitive to it and others aren't. So if you find out that, oh wait, you're super sensitive to every kind of resin and you never want to be around this stuff again, a $200 investment is a lot easier to take in than a $2,600 investment.